Hello and welcome to BierTier, the German engineer. And today we are back with a brand new game to the channel, and that is Poly Bridge 2. Poly Bridge 2 is exactly what you would expect. You're supposed to build bridges, of course, in the most efficient way. So let's see what we got here. I have already completed the first level just to see if the game works. We're gonna do it again, and let's jump right into it. And here we are, and this is what the layout of this game looks like. Poly Bridge 2. We are having here these red anchor points. We have roads, reinforced roads, and wood. And you can kind of see the road here is $200 per meter, where the reinforced road is $400, and our wood is $180 a meter. We have a budget of $10,000, and when we build, for example, a straight across road here, now we have used 2,000 because one of them is 200 meters, and apparently this here is a 10-meter gap. Now the wood, and this is kind of separated here by this little separator, showing that cars cannot drive on it. So we can build something like this here, and just kind of go over, kind of like this here. Build it kind of symmetrical like this here. That's $5,760. We see on the bottom here what the stress level is, and our car made it. I have played this game before at some point. There are some ways to cheese it. You can see kind of like this here on the top left. You can, if you build the roads perfectly, it will just go across it without any sort of struts on it. That is of course not intended and would never work in real life. It's kind of just like cheesing with the game, but yeah, it is what it is. Alright, next level. Now we have here a little bus. The vehicles show us mass, speed, acceleration, and horsepower. Most of those are pretty important. So here, that's only the second level, so we're just gonna build it straight over. Nothing fancy here. We can try something different from what we did a second ago. We can try to build like a strut right there. And we can try to do the same kind of like here. And then from here, we're gonna go straight out. Kind of like this here, and come right back over, connect it into here. Let's see, right there and right there. Nope, this one here is too high. That's what I imagined. That is not holding. This one here broke. It's too much weight on it. So let's see one more time. I see. So we need to come with this one here a tiny little bit further down, maybe something like this. Let's do the same on the other side. See if that balances our load any better. Nope. So the bottom side may not work here. So we can't just build a standard bridge. Pretty straightforward, something like this here. We just take this one here, move it up, and build another one right there. The connection here. Connected. It doesn't connect it because it's too far away. Once we connect it up, we can sort it out. Make this one here a little bit lower. Basically the exact same design that we had on the other one. I may have made these here too short, so we may need to give it a little bit more space so they can hold more weight. The angle here may be too long. No, it's working. So you use $7,100. And that brings us into the top 22 of all players. I'm not sure how, because I mean, how can you be much worse than that? I'm sure you can like cheese it and all sorts of stuff. But if you go into the gallery and we go in sort by budget, he did it with $1,548. Just so you see how this game can be cheesed. So he built a bunch of stuff, slammed it kind of onto the roof of the car, and it just jumps over and somehow makes it. So yeah. Of course, that is not how that is intended. Just like here, none of this here is really intended, and yeah, just what happens when you develop a game with a lot of physics in it. Now we have a really heavy boy here, which means we need our bridge, and we're gonna come straight across here. And now we have steel. Steel is a lot more expensive than wood, but it also gets a lot more weight. Like, it holds so much more weight. What did I turn on that it does that? Stress visibility point of view. Auto triangulation is on. That's the problem. Yeah, I don't want that. I'm gonna build my old triangles, damn it, game. We can build those here over, and you're gonna build them just like that. Maybe this one here a little bit lower. Am I missing one over here? Yes, I am missing one over here, so I need one. This one here needs to disappear. Build a sour road over. And then connect it from here to there, and to there. Now with this one here, we can kind of replicate what we have on the other side. I could just copy it, that would probably be easier, but meh, it's alright. It'll do. So let's see if this here holds. 80% stress, 89%. I don't think I saw 90. Easy peasy, $13,000 used. And we are on position 31,100 in the world. And we're in the top 13% of 250,000 players. I like this here. So we could just go back and we could fiddle with it forever. And maybe that is something we can do. If you guys leave me any suggestions, I'm more than happy to give that a shot. Alright, we're gonna build our shape. We build it over here. And we bring it down to as low as we can. So we're just barely not touching that ship when it comes by. Fill it up. And then we could build a muscle. Let's see. If we go up here, up to here, up to there, back down to here, and back down to here, and then connect these two in, that should be, looks like it's a lot more material, and it is, but it is a lot cheaper than steel is. So I'm going to try to get through this here without any steel. How much that's gonna work, I don't know yet, but we're about to find out. Alright, we have this here, so this one here is going straight into the muscle. Let's just run it. Well, not gonna work until I have actually built a truss. I just wanted to see if it works at all. Apparently this here is not working, so we need to have one here that goes through and connects these up. That should keep it from falling together. Is the ship gonna make it through without tearing it apart? Yes, it is. And our construction down here held, and we are at $10,977, and we didn't use any kind of metal in this bridge. I'm sure you could build it a lot more efficient, like for example this here. Take a look. What is this here? Oh god. Oh no, okay, yeah, it has a break in it, that's why. Include fails. Can I turn it on to no breaks? No, I can't. But yeah, all these here are breaking. Of course it will work, but once again, it's just cheesing the game, trying to get a high score out of it, which can have its appeal. It's just not mine. At least not yet. Okay, what do we have here? We have a double. So now what's happening is those stars here, the car has to get the star and then has to get over here. And the same with the truck down here. So that has to happen. The game wants it this way, so we can go here and we can kind of put it right there so it barely touches it, make it as low as we can. That should work, and fill it up with a road. Perfect. Now the same thing we got to do down here. We need to come from here to here, and we need to come all the way down here, and it should be just low enough that the truck here touches the star. We don't have to go all the way through it or anything like that, so we're gonna do just that. Now we could build two structures that are self-sufficient, or we can build one structure that holds both up. I think I like the idea of having one structure, but let's see. Just because I like it does not mean it's feasible or it makes sense. So we're gonna build you up to here and then up to there, and we're gonna just do slightly in a straight line, so all the force that's going onto here is being transferred right into here. So if I run this right now, well, it's gonna break because nothing else is holding it right now. So let's build us another couple of those bad boys here. Triangles, the strongest shape. We all know it. We all have heard this before. At least I hope so. And let's build this here, see if that all by itself holds it. No, because this here is falling away. It has no other anchor point. So let's give it another anchor point that keeps it just from collapsing, since this is basically a free turning axis. Okay, well, the top car fell down to the bottom car. to the bottom one, and it just smacked it into pieces, which makes sense. That's not really what it is built for. But now what we can do is we can build the same triangles. It doesn't really matter if they're on the top or if they're on the bottom. They're still fulfilling the exact same purpose, no matter on what side they are, right? So we can just build it onto the bottom, kind of connect it up, and this is not a beauty. It will be, hopefully, when I'm done with it. Just gonna adjust this here so it makes sense. Have them all on one axis, all nice and in the middle. Just like that. And now I should be able to connect those here together. Let's see if that does us any good. Nope. This one here has too much force on it, so it needs another strut right there. Let's see how that goes. Ah, barely. We barely made it. This one here broke. So I may have to go and connect those here up as well, which should then provide additional strength. And now we're making it. We used $14,237 out of our $22,000 budget. Top 16%, 33,338. Once again, for just coming up more or less with this design here on the spot and not doing anything else. That's not bad. So we're gonna go for it. First drawbridge. Okay. So it looks like we're building our first drawbridge and we have hydraulics here. And I do not remember how the hydraulics work, so we'll see how that goes. But first of all, I'm gonna build it all the way over. Really just straight. I can't go straight, really. Good grief. Okay. Let me try something different here. Let's take our shape tool, build it to over here, and tell it to fill it, and it'll figure it out for us. And now somehow it's in the middle. I don't know why it didn't do that when I tried, but whatever. Oh, we're gonna go straight up with this one here, connect it to this one and to this one, and then we're gonna do the exact same thing on the other side here and there. Then we're gonna build a very narrow one that is kind of like just off of here. Then we're gonna come further over, kind of in the middle between those two, then go again over, kind of in the middle, and back down to here. Connect those here up. Kind of like this. One more connection is needed right there. And this whole design here, we should be able to, and I'm gonna try this right now. How do we copy around here? I do know that you can copy stuff. There it is, copy, and then flip horizontally, and we should just be able to slap the exact same design on the other side. Now that is efficient. Lots about engineering is basically just to copy and paste, because chances are you're not reinventing the wheel. That is the reality of it. This one here, if you double click it, it becomes a breakable joint. And we can say this here and this here belongs all to number 2. And this side here is all number 1. And what we want to do is we want to contract it. So let's just run it, see if it holds it all. It opens up, the ship comes through. Closes back down. And then our little moped is driving right across it like nothing has ever happened. But just from standing here, it has a lot of stress on it because I didn't build it right. So just give me 1 second here. Let's try to fix this thing up. I don't think we need it anywhere near this high. We can just build it kind of like this here. We can come maybe down. I don't know how far I can push it, but we're about to find out. This here should be looking symmetrical. That may not work. May not work, but we will see. It's working. Wonderful. Now if it survives the moped, which it should, since the moped is not very fast and it has barely any... No, it does not. Wow. Okay. So this here needs to be 1 higher so it can carry more load. Let's speed it up so the ship here comes through faster. And the moped made it. So here we have it. $13,728 out of a $25,000 budget. We are number 43,079 on the leaderboard, in the top 21 of all players. And if they would get rid of all the janky ones that are just like messing with the game's physics, it will probably be much higher than that. So I'm pretty happy with it. I would say we're gonna do one more, see how it goes. We have our taxi. Our taxi needs to go to the top, then it needs to come back down and hits this one here. So that's basically what it's gonna do. All right, first of all, our draw tool, come here all the way up there and then fill it up with roads. Can't get around that anyway. And then we can build, what could we do here? Let's see. Let's try to build our triangle structure on the bottom. Once again, we're just gonna start kind of janky because it needs to be adjusted anyway, if I like it or not. We shouldn't even have to connect it up to here, I believe. I think that it will hold itself up. Let's build tiny little triangles, kind of like this here. Yep, those look fine. Right in the middle there. Now we may need to use a steel beam. The steel beam should preferably be as straight as possible into here, so all the force gets leveraged. So what? Ooh, okay, that doesn't hold. Let's try this again. Let's build one more on here just to see if that makes a difference. Oh yeah, it cannot hold. Wait, before we build this here, because I do believe we don't need it. If I don't build those connections in here, it doesn't even have a chance to hold. There you go. Figured that would work. That's less than 50% of our budget. Top 16%. Number 33,282. That's us right there. Not bad at all. And pretty simple bridge. On the top of it, I'm sure it's scary as hell because you don't have anything that holds you on the bridge. But that is just how it goes around here. Let's do one more. One more. Once I get started on something, it's hard to stop. So let's just build this here straight over. And we got ropes. Ropes and cables. Cables are made out of metal and ropes are, well, made out of, I don't know. What are they made out of? Let's build those connections here. Can just do that. And now we have those ropes here. And I can just place the rope here. And I can place the rope here. And over there. Not over there. Over here. And another one. 1, 2, 3 away. 1, 2, 3 over here. So let's build it symmetrical. See if that holds at all. It may not. But it does. Look at that. $21,000. Pretty straightforward. And we're in the top 40%. I'm wondering if we actually need that many of them. If I get rid of these ropes here and I just build a straight one down here, is that going to be enough? If I build this one here up, that's not going to hold. No, that's not going to hold. That's what I thought. Because for that to hold, we would have to build it like this. You have to come up a tiny little bit, but would that then at the end of the day save us any money? Now that's the question that I have. And we can then come back down here. Yeah, now it's holding, and we are now at 18,556. And I already forgot what we had before, but it's better. Much better, actually. So those few dollars got us into the top 6%. So just a tiny little change every once in a while can change everything that you're working on. Should we do one more? One more? Yeah, let's do one more. But now I'm sure, okay, guys? All right, let's come across here. Before we do anything, we need a road. And we don't really have a choice. So let's come up to here and back down. Up to here and back down. Up to here and back down. And from here, we should be able to come kind of like, let's see, maybe right there. No, it just needs to be kind of like here. Then right there. No, that's not the right position here. Let me see. Is that better? It's not really better. How about this? That would be perfect. Can I do this on the other side? Yeah, that will work. Beautiful. Then we're going to build here a triangle out of this here. That's going to hold our whole middle section up. And we're going to come back down around. More triangles connecting the tops. If you forget that, everything will collapse immediately. Our triangles over here, taking the force from the load of this bulldozer or whatever exactly that is, coming across. It should transfer the force into here and then all the way in a exactly straight line down there. Then exactly the same thing over here. Once it passes by here, it should come down here and it should all be on this triangle. Let's see if we can see that. Let me slow it down before I start it up. We're at 300%. So we can see these here turning red. Our whole stress, our whole force is in here, and now it transfers to this side. So you don't need to be a genius or a civil engineer or anything to figure that one out. That is actually engineering 101. And once you understand how forces works, it makes everything around you so much easier. Leverage, for example. There are lots of concepts like this that you can learn without having to spend, I don't even know, 100 grand here in the United States and getting an engineering degree. And they're useful in your everyday life. But we are done for today. Next time around, we are jumping gaps apparently, so that's going to be interesting. But for today, that is it. If you enjoy the content, please subscribe to the channel, like the video, and leave a comment below. I'll take any tips, tricks, any sort of feedback you may have, and if you would like to see me play another game, please let me know. I'm always open for ideas. I may not take up every idea, but I'm certainly open to it. But that's it for today. Thank you and peace.